Hello and welcome to this video where we're going to be looking at composite functions. Imagine I have two functions, f of x, which is going to be equal to 3x, and g of x, which is going to be 2x plus 6. Let's pick some values for x. Let's go for 3 and 5. So if x was 3, 3x would be 3 lots of 3, which is 9, and 5 lots of 3, 15. Now let's imagine I take these values of f of x and I use those as my x values for my g of x. So these outputs become my new inputs. So let's use 9 and 15. So if x is 9, I need 2 lots of 9 plus 6 if I'm going to do g of x. 2 9s are 18, add 6 is 24. And 2 15s are 30, add 6 is 36. Now composite functions are concerned with how can I get from this value to this value, or this value to this value, in one function, rather than putting it through two functions. And the way we write that down is either fg of x or g f of x, depending on which function we did first. And you might be able to spot it for this one, but what you do to get from here to here is you multiply this by 6, 6 3s are 18, then add 6, that will give you 24, and similarly 6 5s are 30, add 6 is 36. So the function that gets from here to here is 6x, add 6, but what we need to be able to do is work that out in a rigorous way. Let's have a look at some examples then. So it says calculate g f of x. That is another way of writing g of f of x. We tend to just not write this bracket because it gets quite crazy with brackets the more functions of functions you do. So what I need to do here is do f of x first, and then whatever I get for f of x I put into g of x. So this is a bit like the one we did in our example. To do this algebraically, what you do is you take g of x, you write that down, and you replace all of the x's with whatever the f of x function was, so in this case 3x. So I'm going to write out g of x, so g of x equals 2x plus 6, but then g of f of x is the same, apart from every time I get to an x, I write the f of x function in. So the f of x function up here was 3x, so 2x, but that's 3x, plus 6, and then I just simplify this, 2 lots of 3x is 6x, plus 6. So this is the one from our example. Now f of g of x is slightly different. That's where you're going to do g of x first, and then whatever you get for that, that becomes your x value for the function f. So this time I'm going to write out f of x, which is 3x, and then fg of x. I write this out again, but everywhere I get to an x, I'm going to write this whole function. So I've got 3 lots of x, I'm going to put this in a bracket, because it's the whole function multiplied, and then I just simplify. So 3 times 2, 6x, and then 3 times 6 plus 18. Let's have a look at a second example then, in particular one where we have to be very careful and make sure we have those brackets. So we're going to do g of f of x again first, so let's write out g of x. G of x equals 2x plus 3, and now g of f of x means I write that out again, only I replace all of the x's with this whole function here. So I've got 2x, now I'm going to replace x with x squared plus 5, and I've still got this plus 3 on the end. So this bit here was my x, that became my f of x. Multiply this out, I get 2x squared plus 10, and I've still got that plus 3 on the end, and so I get 2x squared plus 13. For fg of x then, well, let's write out f this time. F of x equals x squared plus 5. So f of g of x, I'm going to need to write that out again, but everywhere there's an x, I'm going to write this whole function in brackets. So it's this whole function squared. So it's 2x plus 3 in brackets squared, and then still plus 5 on the end. Now expanding this, you've got to be very careful. Some people would incorrectly just do 2x and square that and 3 and square that. It's not. It's the same as expanding a double bracket. So I've got 2x plus 3 multiplied by another 2x plus 3, which comes out as 2x times 2x is 4x squared, 3x times 2x is plus 6x, I've got another 6x from the other 2x and 3, plus 9 plus 5. And if I simplify all of that, I get 4x squared plus 12x, and the 9 add 5 gives me 14. Okay, here's our first set of practice questions. Press pause, try these, and then when you want the answers, press play and I'll tell you what they were. Okay, here are the answers then. So for the first one, g of x equals 3x plus 1. So gf of x equals 3 lots of 6x subtract 5 plus 1. So that's 18x. Subtract 15 plus 1, which equals 18x. Subtract 14. For this next one here, f of x equals 6 lots of x minus 5. So I end up with fg of x equals 6 lots of 3x plus 1, subtract 5, which is 18x, plus 6, subtract 5, which is 18x plus 1. Okay, here we have a second set of examples. Press pause, have a go at these, and when you want the answers, press play and I'll tell you what they were. Okay, so g of f of x is equal to, well, we take x squared and we need to replace all of the x's with 3x plus 4. So we've got 3x plus 4 all squared, which we know is a double bracket, 3x plus 4 multiplied by itself, which will give us 4 terms, and they are 9x squared plus 12x plus another 12x plus 16, which simplifies to 9x squared plus 24x plus 16. So fg of x for this one means we're going to take the f function, which was 3x plus 4, and everywhere there's an x, we're going to replace that with x squared plus 4. This one's quite simple, it's just 3x squared plus 4. Okay, here are a final set of practice questions for you to have a go at. Press pause, try these. When you want the answers, press play and I'll tell you what they were. Okay, here are the answers then. So for gf of x, we need to write out g, which is 2x, but everywhere there's an x, I need to put this whole f function, which is x plus 10 over 5. Then when you multiply a fraction by an integer, so 2, you're just multiplying the numerator. So this is the same as doing 2 lots of x plus 10 over 5, which is 2x plus 20 all over 5. So a common mistake here would be times both top and bottom by 2, but that just gives you the same thing back, unfortunately, and that's wrong. Fg of x, we take the f function, which is x plus 10, and everywhere there's an x, I write 2x. So I've got 2x plus 10 over 5, which is simply 2x plus 10 over 5. That completes this video on composite functions.